Imagine I hand you 5 playing cards shuffled. Your job, arrange them smallest to largest. Watch what you do without thinking. You glance at 2 cards, decide which is smaller, swap them if they are in the wrong order and move on. That is an algorithm. It has a name. It is called bubble sort. By the end of the next 15 minutes you will write it from scratch, see exactly why it works, and understand the one reason you should almost never use it in real code. Here is the path, what an algorithm actually is. The one rule that makes sorting hard for a computer, the bubble sort idea, the 8 lines of Python. One example walked step by step. Why it is slow, what you should use in real code. Start with the word itself. An algorithm is a recipe, a finite list of exact steps that turns an input into an output. Think of making a peanut butter sandwich. Input, bread, peanut butter, jelly. Output, sandwich. Steps, open the bread bag, spread peanut butter on one slice, spread jelly on the other, press them together, nothing magical, just steps. Sorting is the same shape. Input, a shuffled list. Output, the same list in order. Steps, that is the question. Every sorting algorithm ever invented is a different answer to, what are the steps? Before we invent any steps, we need to understand one hard rule. Your eyes can scan a row of numbers and spot the biggest one in a split second. A computer cannot do that. A computer can only compare 2 numbers at a time. Is A bigger than B? Yes or no? One pair, one question, one answer. To sort a whole list, it has to ask that question over and over, picking a different pair each time. Every sorting algorithm you will ever meet is just a different strategy for choosing which pair to compare next. Bubble sort has the simplest possible strategy. Always compare the next 2 neighbors. Walk down the list. That is it. Here is the idea in one sentence. Walk through the list, compare each pair of neighbors, and if they are in the wrong order, swap them. We call one full walk through the list a pass. Watch what happens on the first pass. Every time we bump into a number that is bigger than its right-hand neighbor, we swap them. So the biggest number we have seen so far keeps getting passed along to the right. It bubbles to the end. That is where the name comes from. Big values rise to the top of the list the way air bubbles rise through water. By the end of pass 1, the largest value in the whole list is guaranteed to be in its final position at the far right. Do another pass, and the second largest slides into place. After n passes, everyone is home. 8 lines of Python. Define a function that takes a list called R. Store its length in n so we do not have to recompute it every loop. Outer loop, do n passes. Inner loop, for every index j up to the end of the unsorted part. If the value at position j is greater than the value at j plus 1, they are out of order. Swap them in one line using Python's tuple assignment. Return the sorted list. Let's run it on a concrete list. 5, 2, 8, 1, 4, pass 1, compare 5 and 2, 5 is bigger, swap. The list is now 2, 5, 8, 1, 4, compare 5 and 8, 5 is smaller, no swap, compare 8 and 1, 8 is bigger, swap. The list is 2, 5, 1, 8, 4, compare 8 and 4, 8 is bigger, swap. The list is 2, 5, 1, 4, 8. End of pass 1. 8 has bubbled to its final spot. Pass 2, 2 and 5, fine. 5 and 1, swap. Now 2, 1, 5, 4, 8, 5 and 4, swap. Now 2, 1, 4, 5, 8. End of pass 2, 5 is home, pass 3, 2 and 1, swap. Now 1, 2, 4, 5, 8, 2 and 4, fine. End of pass 3, 4 is home, pass 4, 1 and 2, fine. Sorted. Final list 1, 2, 4, 5, 8. 10 comparisons, 4 swaps, 4 passes. Now the bad news. Count the work. For a list of length n, we do roughly n times n comparisons. A list of 5 took about 20. A list of 50 takes about 2,500. A list of 500 takes 250,000. A list of 5,000 takes 25 million. A list of 50,000 takes 2.5 billion comparisons. A modern laptop does about 100 million comparisons a second. So 50,000 items, 25 seconds. That is what computer scientists mean when they write O of n squared. Double the list, quadruple the work. 10 times the list, 100 times the work. Real sorting algorithms, quicksort, mergesort, timsort, are O of n log n. The same 50,000 item list finishes in milliseconds. So when do you use bubble sort? In production, almost never. Python's built-in sorted function uses timsort, which is faster and written by people who have spent decades polishing it. Use that. The only honest case for bubble sort is tiny lists where the overhead of a smarter algorithm is not worth it. 10 items or fewer. Even then, a good programmer would reach for insertion sort instead. But here is what bubble sort is perfect for. It is the clearest possible window into what sorting mechanically is. Every computer science student in the world writes it by hand at least once. Every big tech coding interview starts here as a warm-up. You have now written it too, and you understand why it is slow, which is a thing most beginners do not. 5 minutes ago you did not know what an algorithm was. Now you have written one, traced it step by step, and understood its performance. Next up, quicksort. Same job, fundamentally different idea, roughly the square root of the work. Subscribe if you want that lesson, and comment with the first algorithm that made sense to you. I read them all.